Welcome back as we work our way through Unit 1. Today we're going to be taking a look at solving linear inequalities. We've dealt a little bit of the equations. Now we get to start getting into some additional values with inequalities. A couple of things just to keep in mind, like we have mentioned up here at the top. If you multiply or divide both sides by the same negative number in order to get your variable term alone, you have to remember to reverse or flip the inequality arrow. Some of you may have, when we get involved here with interval notation and also making marks on our graphs, you may have dealt before with open circle, closed circle. We're going to start working with parentheses and brackets because you'll start to see that's going to help us with memorizing our interval notation. So here, a couple things to keep note of. When we're doing these, you like to have whatever your value is with your variable in the middle. And we want at least, okay, we need a minimum of 3 numbers on your number line, and this is to show that you have number sense. In other words, if you have negatives and you wrote -2, -3, -4, you're showing me you don't get it, and we need to have equal values on there to be consistent. So this is stated as x is less than 3. So less than heads to the left. I've always found that to be an easy thing to think about. Now, it doesn't mean that your arrow is always going to match the inequality arrow. We have to get out of that habit of thinking that's the case. Arrow towards your variable is going to be less than. Less than heads left, and that's the reason that that's the way it is. Okay, here we have x is greater than or equal to -2. So if we put -2 in the middle, what number goes on the right side? -1 or -3? -1. So we get that in there. Again, it's or equal to, greater than goes to the right, and we draw our arrow to the right. Now here's the part that you may not be as familiar with, interval notation. We want to describe what the solution set's going to be without a picture. So my graph, we always work from left to right. We're like, left, the arrow goes forever. How do I do that? We signify this arrow going forever to the left. It's infinite in length, but since it's going to the left, it's negative infinity. It's like a negative sideways 8. That always has a parenthesis. Any infinity does. And till it comes as far as it does to the right at 3, where there's a parenthesis. So this is our way of saying this arrow is going everywhere from all the way in negative infinity all the way up to 3 and then stopping, not including 3 though. Over here, again, left to right, here's our furthest point left. It's at -2, and since that was or equal to, we use the bracket just like we did on the graph. But since we're going to the right positive, we're going to go to positive infinity and work it that way. So that's how these are going to work in general. Okay, they may not always be ready to go right away. We may have to solve. Add the 8 to both sides. Divide by 5. And then again, solution in the middle. Values to each side to show number sense. This is y is less than, arrows pointing at y. Less than goes to the left. And the interval notation will be very similar to the example right up above. I start out here at negative infinity, work my way up to 4, and it stops there, not including 4, so we use the parenthesis. Next example, that's a positive 5, so we're going to minus it from each side. And when I divide by a negative, okay, this is important. Remember that inequality arrow is going to flip. So in this case, I'm dividing by a negative. I'm going to flip or reverse the inequality arrow. -11, -10, -12. Or equal to means we're going to be using a bracket. Less than means we're going to be going left. And again, very similar to what we're doing in example 1 in this section, starting with negative infinity, but when we get to the negative 11, it's included this time, it's or equal to, so we have to use a bracket, and that does matter. Keep working here, add the 7. Now some of you may say, well, what if I want to get rid of the fraction first? I wouldn't suggest that, because to get rid of the fraction here, multiply by 2, I'd also have to multiply the negative 7 and the 2 by 2. And sometimes you might forget about this one. But when I get here, again, you have choices. You can either multiply by the 2 and then divide by 3, or again, my suggestion is to just multiply both sides by the reciprocal, because then those cancel. And again, I can always turn the 9 into a fraction if I wanted to. 9 times 2 is 18, divided by 3 is 6. And again, no or equal to, it's a parenthesis, greater than's heading to the right. Okay, and again, we start at the leftmost point, so we start at the 6, go off to infinity. So far, so good. Now we have variables working on both sides. Okay, we're going to take a look at the first two. I always like getting all of my x's to where it stays positive. If you always like them to the left, that's fine. Add my 1 over and divide by 4. Now again, 2 divided by 4. Now 4 divided by 2 is a half. You're like, what do I do with that? Well, I could subtract a half and add a half. Okay? Here's where I'm talking about with needing to be careful on your arrows. X is greater than 1/2. The arrow is eating my variable, which means greater than. Greater than goes to the right. That's what you've got to keep reminding yourself. Arrow opening to the variable is greater than, goes to the right. Arrow pointing at the variable, less than, goes to the left. Start at the left of my graph, head off to the right. And I'm set. And one more here, always distribute first if you can. And again, myself, I like to make sure we're staying positive. Oh, excuse me. Subtract my 12 over. Again, just because it became negative does not mean that I'm flipping the arrow. That's only if I multiply or divide. So again, I'm ready to go here. But again, I have to be cautious. X is less than. The arrow is pointing at X. Less than goes left. Or equal to also means that goes left. And we work that out. Actually, let's take a look at 6, because we're going to run into one more twist here. If I add my n, subtract my 4, and divide by 8, 2 divided by 8 is a quarter. Okay, now how am I going to do this? Again, I cannot just put 0 and 1, because between 0 and 1/4 is 1/4. Between 1/4 and 1 is 3/4. You have to be consistent. So I'm going to subtract 1/4, which gets me 0. And I'm going to add 1/4. So if you think about it, if you have a quarter of a pizza, and then you get another quarter, how much you got? Got a half. But again, arrow open to the variable is greater than. Oh, and I see I forgot my interval on the last one. Left to right. Okay, left to right. And you keep noticing, every time I have an infinity, it's always a parenthesis. That's never going to be a bracket, ever. Okay, one more thing before we flip over. Compound inequalities. We're going to get into some bigger ones. Typically, they're joined by either the and or an or. And sometimes the and doesn't, but we'll get into that. And problems are restrictive. Only what you have in common is what we're going to take here. Or problems are non-restrictive. In other words, I like to call this anything goes. Anything that either has works. Here it's only what you have in common. So let's flip over and check this out. Okay, so when an inequality says that x can be less than or equal to -3 or greater than 1, it's asking that we represent things. Let me scooch down a little more here because I'm reading and you're on a different one than I am. So here, when I see one of a three-part inequality, and problems typically look like a three-parter, or it'll say the word and. So what I'm generally going to do is I'm going to look at both of these separately. Here it says x is greater than or equal to -2. So here's -2. Got my arrow going to the right. Okay, if I cover up the other part, it says x is less than 1. Less than's a parenthesis. You're like, but they're going to smash into each other. Exactly. They're going to combine in the middle, and that's going to cover all of our numbers that are between -2 and 1. That's another way of saying this. So you color in between. Those are set. And that actually has you somewhat into interval notation already. Left to right. No infinity this time because it stops. The next one, though, gets split up, and there's an or in the middle. So let's do these separately. X is less than -1. Okay, there's my x is less than -1. And here's my x is greater than or equal to 2. Now you notice those don't combine in the middle. Those go opposite each other. So typically, and problems tend to come together for their solution, and or problems go opposite or apart from each other. Okay. Now the interval notation on this one's a little more interesting as well. Because again, you're like, well, how do I do this? It's broken up. Start from the left, which is again -infinity. And it stops here at -1, but you're like, but that's not the whole thing. That's just this part. So we're going to combine that. So let's write our other one first. Our other one starts at 2, heads off to +infinity, but I want those combined. So we use this thing called U, which is called union. I'm going to union this part of the answer going here and this part of the answer going the other way. But you have to have that U in the middle if it breaks up into two pieces. Okay. So let's take a look at a few down here and see what we've got working. So number 8, you're like, ooh, this is kind of funny. Working on getting t alone in the middle. So I'm going to add 8 to all sides. The left, the middle, and the right. So I've added 8 to all three. Now it's just the 3t in the middle, and I can divide by 3 to get that t alone. So you're like, okay. So when I start doing my number line, I want to make sure my two end numbers end up there. They're both or equal to. And similar to what we saw up above in the very first example at the top of the page, when we get these three-part inequalities, they're typically ands. Ands come together most of the time. But just in case, t is greater than or equal to -2. Excuse me, +2. That'd be going to the right. T is less than or equal to 6. Okay, that's going to the left, and just as we suspected, they combine in the middle. Interval notation on ands are great, because you're basically just taking your two endpoints and you're copying what you see in the picture. Brackets, brackets, start at 2, end at 6, you're good. Okay, let's take a look at one more of these. Number 9, I can add 3 to all sides. Whatever I do to one part, I do to all 3 when it's a compound inequality. Caught myself before you caught me, hopefully. Divide by 3. And just like before, now sometimes you're like, well, I don't have enough lines here. Sometimes maybe we're going to have to count by a different quantity, maybe 2's. X is less than 6. X is greater than -3 or equal to. And again, it's just my endpoints, being careful with my symbols. Okay? Nothing too bad. get to the bottom here. And we have our OR statements. So let's take a look at 11 and 13. We do them each separately. So I'll minus the 3 and divide by 2. And here I'll add my 7 and divide by 4. So I got 1 and 4. I want to make sure those two numbers get on my number line. X is less than 1. Less than goes left. X is greater than 4. They separate just like we thought, and again, like we did up above, do them in pieces. Just do the interval notation for this first, which would be negative infinity to 1. Do your interval notation for the right part, from 4 to infinity. And again, I need to bring those together, so that's a union. Okay. And then 13 minus the 7 over. Divide by negative 2. What do I do when I divide both sides by a negative? We flip the arrow. We make it its reverse. Here, minus the 5 is negative 3. Divide by 3. You're like, well, there's a negative there, and you didn't flip it. But the only time I flip is when I'm dividing or multiplying by a negative number to both sides, not just because it becomes negative. So get my numbers in here. X is greater than or equal to positive 2. X is less than 1. And again, with our interval notation, left to right. Okay. Hopefully this helps you out. If you have any questions, let me know.